Welcome to everybody at this third webinar in cooperation with the VIAVI solution. The webinar is focused on the application of a NIR sensor at the wet granulation process in a high shear. I am here in IMA Lab in the process room where is installed our high shear wet granulator rotocube, and I am together with Emiliano, that is our consolidated partner for the application of a NIR sensor to all our equipments and machines supplied for manufacturing of oral solid dosage forms.
Thank you, Giusy, and thank you, Hima, for the hospitality. I am the account manager for the MicroNIR product line in EMEA and LATAM, and I am very excited to be here because we are really getting a lot of requests from the field for this kind of application.
Granulation is the crucial first step in creating a robust, solid oral dosage form. Wet granulation in high shear is the most preferred method in creating high-quality granules, suitable for tablet compression and capsule filling formulations. Although this method is well established, the identification of endpoint during each phase of the process is still challenging.
Giusy, what is exactly the definition of the endpoint in the granulation process?
Basically, the endpoint in granulation can be defined as the point at which granules achieve the desired properties as good uniformity, density, particle size distribution, and residual moisture. It is important to consider that each single step in high shear granulation requires an endpoint. Even if the wet mixing phase has the greatest impact in determining the endpoint, however, the starting dry mix as well as the liquid addition play an important role in granule formation.
As we well know, PAT means process understanding. Manufacturing companies are starting from the assumption that using raw material from validated suppliers gives constant process. In reality, despite all the effort, it's not possible to guarantee that the final target is constant without studying how the experimental domain is impacted by quality attributes. FDA requires a very accurate and precise method to determine the granulation endpoint. In the traditional manner, the operator are taking the granules in the hand and squeezing a bit to see the quality of the granule. NIR is very sensible to the moisture content, and therefore it can be a very useful technology to measure all the granulation process from the dry mix to the wetting, from the massing to the final drying point.
The final granules properties are strictly correlated to a huge number of process parameters: ball geometry, batch size, impeller speed, amount and method of binder addition. What is important is to find endpoints having high reproducibility by controlling all the process variables. One of the oldest methods for endpoint determination is based on the duration of the mixing phase for both dry and wet mixing. The limitations of this method could lead to inaccurate results due to the variability of the starting raw materials, for instance from different suppliers. One of the most used devices for the endpoint determination in high shear is the torque meter, mounted directly onto the impeller drive shaft. This method measures the impeller torque in Newton meter in real time by correlating the measurement to the granule growth.
Back in 2012, VIAVI Solution introduced the first MicroNIR called 1700. This device is still the smallest NIR in the market and allows us to have a smart sensor applied to process control, also in ATEX environment. MicroNIR sensors are equipped with a near linear variable filter. operating without any moving part and therefore completely maintenance free. In particular, the installation and the integration of an NIR sensor on a NIR shear mixer is really important for two reasons. First, when it's quite complicated to follow the process just looking at the impeller torque. Second, when we want to measure a chemical property instead of a physical property of our samples. In this plot, you can see spectra as is and spectra after normalization, in particular a first derivative. It's very interesting to look at the peak at 1428 nanometer that is mainly due to the water. During the granulation process, after the dry mixing phase, water is added to the powder. As expected, this peak becomes taller and taller, but you can also notice that the perfect symmetry is lost. This is probably due to the chemical bonds that are changing due to the transition between liquid bridge, solid bridge and snowball structure. As we have already seen in our previous webinar, a very simple and useful approach to do process monitoring is the so-called moving block standard deviation. In this specific application, a PATU is installed and is acquiring spectra every second. A standard deviation is calculated on a block of 5. If the spectra are changing, the standard deviation will change and vice versa. Therefore, the moving block standard deviation is a unique and simple solution for process monitoring, without the need to get a real calibration that is very time consuming. In this plot is represented a moving block standard deviation, red line, and also a moving block mean, green light, compared with the impeller torque, blue line. In the graph we can clearly see how the NIR is able to show in a very nice way the three process phases. The first phase is the so-called dry mix that is not visible using the torque, where after a first variation the moving block standard deviation go down to 0, showing that our ingredients are mixed properly. The second phase is called wetting or primary granulation, and again is not visible just using the impeller torque. While we are adding water, we have the moving block standard deviation that goes up continuously. The third phase is called massing or secondary granulation, and this is the only step that we can also see with the torque meter. But also the NIR show a very clear valley on the moving block standard deviation in correspondence of the flex of the impeller torque. Another multivariate approach that is very interesting is the principal component analysis, called PCA. In this case, our 125 wavelengths are synthesized into few principal components, normally 5, 6, 7 components that are containing the majority of the spectral information. This plot shows PC1 and PC2 and the impeller torque over the time. As you can see, the three process steps are very clear to identify. Under this perspective, principal component analysis is not bringing any value, but we are just confirming what we have already seen with the moving block standard deviation. A closer look at the loading plot shows something very interesting. The PC1 loading is clearly assignable for the variation in the solid bridge, and the PC2 is strictly connected to the liquid bridge. Therefore, the principal component analysis allows a big enhancement in the process understanding. With the introduction of the MicroNIR Pro 3.2, we have introduced a new functionality called Golden Batch that allows us to compare historical batch recorded on the software. The so-called Golden Batch is nothing else than the average of different batches already acquired. In the graph is displayed with a yellow line. The minimum is the dashed blue line and the maximum is the dashed red line. In this way, to keep under control your process is very simple. You just need to look at where it's laying down and check that is inside the specification defined based on historical data. If there is an overlapping with the golden batch is fine, or if you see that is going out of the dashed borders, means that there is a red flag and the laboratory has to open an investigation.
If you have questions, please type them in Q&A box. We will stay online in order to reply to all of you. Thank you very much for your attention.
Thank you very much also from my side, and stay in touch.